In this video and the future videos, we are going to solve a lot of trigonometric identity proofs. So please write down these problems in a worksheet and try it yourself first. If you are finding difficulty, then you can continue to watch the video, or after you solve, please come back to the video and verify or see the approach that I have taken, and also you can compare it with yours. So please pause the video now and try it yourself. Okay, I hope you have paused the video and tried it yourself, but let's try to solve it now. So here we have to prove that cosecant theta minus cot theta the whole square is 1 minus cos theta divided by 1 plus cos theta. So here you observe that the left hand side has cosecant or sine, the inverse, and cot, but the right hand side has only cos theta. So let's solve this by changing cosecant theta and cot theta to their original definitions. So cosecant theta can be written as 1 by sine theta, and cot theta can be written as cos theta by sine theta, and this is a whole square. So this can be further written as 1 minus cos theta the whole square divided by sine square theta. We just applied the square to the numerator and the denominator. Now if you observe the right hand side that we want to achieve, it only has cos theta. So we have to convert this sine square theta to cos theta. So let us apply the identity. We know that cos square theta plus sine square theta is equal to 1. So sine square theta alone can be written as 1 minus cos square theta. So 1 minus cos square theta, we can change this to 1 plus cos theta times 1 minus cos theta. We just applied a plus b times a minus b, which is a square minus b square. We just applied this algebraic equation here. So let's replace the denominator. So this will be 1 minus cos theta the whole square divided by 1 plus cos theta times 1 minus cos theta. So the numerator has 1 minus cos theta the whole square, and the denominator has one of the 1 minus cos thetas. So we can cancel this and one of the square and the squares. So this is how we get the proof that we require. So we get it as 1 minus cos theta divided by 1 plus cos theta. Let's solve the second problem. Here we have to prove that cos A divided by 1 plus sine A plus 1 plus sine A divided by cos A is equal to 2 times secant A. Now to approach this problem, let's solve the common denominator. So the first part of the equation does not have 1 plus sine A in the numerator, and the second part does not have 1 plus cos A in the numerator. So we just cross multiply the denominators, and that will give us the common denominator. So cos A times cos A is cos square A plus 1 plus sine A the whole square divided by cos A times 1 plus sine A. So all that we did is multiply the denominators so that we arrive at a common denominator. Now let's expand this 1 plus sine A the whole square. So we will get cos A square plus 1 plus sine square A plus 2 times sine A divided by, the denominator remains the same, 1 plus sine A times cos A. Now here if we observe cos square A and sine square A, we can mark this as 1. So this will be 1 plus 1, this is an existing one here, plus 2 times sine A divided by cos A times 1 plus sine A. Now 1 plus 1 is 2 and plus 2 sine A. So we can consider 2 as common. So 2 times 1 plus sin A divided by cos A times 1 plus sin A. So we can cancel out 1 plus sin A from the numerator and denominator. We will have 2 divided by cos A, which is nothing but 2 times secant A. So this is how you can solve the second problem. Let me know in the comments if you approached with the same method or if it's something different. Let's continue with the third video now. Let's solve the third problem now. So here we have to prove that tan theta by 1 minus cos theta plus cot theta by 1 minus tan theta is 1 plus secant theta cosecant theta. So here we clearly see that the left hand side has tan and cot, and the right hand side that we want to achieve has secant and cosecant, which is nothing but 1 by cos and 1 by sine. So to achieve that, we have to define tan theta in terms of sine and cos, and we apply the same method to cot as well. So this will be sine theta by cos theta divided by 1 minus cos theta by sine theta plus cot theta is cos theta by sine theta divided by 1 minus sine theta by cos theta. Now we will solve the denominator for commonality. So 1 minus cos theta, to find a common denominator, we can rearrange it as sine theta by cos theta divided by sine theta minus cos theta divided by sine theta. Then the second part plus cos theta by sine theta divided by, we find a common here, this will be cos theta minus sine theta divided by cos theta. Now what we can do is we can rearrange this to have a single layer of denominator and numerators. So when the denominator moves above the line, it becomes sine square theta, and same applies to here as well. So the denominator multiplies with the numerator here, and it becomes cos square theta. So if we rearrange this, we would get sine square theta divided by then the cos theta of the denominator times sine theta minus cos theta plus cos square theta divided by the sine theta here as a common times cos theta minus sine theta. Now take a moment and just observe what we are trying to achieve here. So we want to go back to 1 plus secant theta cosecant theta. So somehow we have to rearrange this equation and get few cancelling terms. Now here we observe that in the denominator here we see sine theta minus cos theta in the first part, and in the second part we see cos theta minus sine theta. So if we multiply this second part by minus 1 and also divided by minus 1, we can get a common denominator, which is sine theta minus cos theta. So let's do it. And then again we can take a common denominator here, sine theta and cos theta, we can cross multiply. So this would be sine theta will go as the denominator multiplies with the numerator here. So to take a common denominator, so it will be sine cube theta, and this cos theta will be multiplied by cos square theta, but there is a negative sign, minus cos cube theta divided by sine theta cos theta and sine theta minus cos theta is the common denominator now. How did we achieve this? We just multiplied and divided the second part, and when we multiply this minus 1 with cos theta, it becomes minus cos theta, and this part changes to plus sine theta. So we get a common denominator. Now this is of the format a cube minus b cube. So what do we know about a cube minus b cube? A cube minus b cube is a minus b times a square plus ab plus b square. Now if you apply this, it would change to sine theta minus cos theta, which is a minus b, and this will be sine square theta plus sine theta cos theta plus cos square theta. We just applied a cube minus b cube as shown above, and then the numerator would remain the same, which is sine theta cos theta times sine theta minus cos theta. Now we see sine theta minus cos theta common between numerator and denominator. That we can cancel. Then we also observe that sine square theta plus cos square theta is 1. So we will have 1 plus sine theta cos theta divided by sine theta cos theta. So now if we divide each part of the numerator with sine theta cos theta, we will have 1 by sine theta cos theta plus 1, which is nothing but 1 plus secant theta cosecant theta. So this is how we can arrive at 1 plus cosecant theta secant theta. So please keep in mind the algebraic equations a cube minus b cube, and also note down a cube plus b cube in a simplified format. So we can apply all this to solve trigonometric identities. Thank you for watching. Please share it with your students or also your friends. Like the video and subscribe to the channel. I'll see you in the next video.